In this video, we're going to talk about doing integration where the integration ends up involving the inverse trig functions. Most importantly, arcsine and arctangent. It seems like these are the two inverse trig functions that get used the most often, especially arctangent. That gets used when you do partial fractions, if you've seen integration by partial fractions. If not, I assume if you're watching this, you'll probably see it at some point in the near future. So recall that the derivative of arcsine is 1 over the square root of 1 minus x squared. Well, that means if you integrate 1 over the square root of 1 minus x squared, you simply get arcsine right back. So this is one of our integration formulas. And likewise, the derivative of arctangent is 1 over 1 plus x squared. Well, that means if you integrate 1 over 1 plus x squared, you get arctangent back. And a little more generically, if you integrate 1 over a squared, where a is some number, that's not a 9, sorry for my bad handwriting, so a squared plus x squared, you get 1 over the a value, arctangent of x over a plus c. Okay, and you can justify this without too much trouble, and I'll actually kind of show you a similar idea on where that comes from. So let's do some problems here with some integration. See, I'm trying to find a couple good ones here. Alright, so, well, suppose simply, let's start off easy enough. Suppose it was 1 over 9 plus x squared. Well, this again is that arctangent formula I was just showing you. You could rewrite this as 1 over 3 squared plus x squared. So now this is like the 3 is my a value from that other generic formula. And if you integrate, it says you get 1 over the a value, which in this case is 3, arctangent of x over 3 plus c. And that is your derivative. Excuse me, your antiderivative. Let's look at another. So suppose here we had to integrate arcsine of x over the square root of 1 minus x squared dx. Well, recall the derivative of arcsine is 1 over the square root of 1 minus x squared. So here we could simply do a u substitution, letting u equal arcsine of x. Du, again, is going to be the stuff we need in the denominator, 1 over the square root of 1 minus x squared dx. So we can actually rewrite this entire integral as simply the integral of u du. And if we integrate u to the first, we'll get u squared over 2 plus c. And now all we have to do is just plug our u value back in. It says we get arcsine squared over 2 plus c. And that'll be our antiderivative. Okay, so definitely you need to notice, hey, well, the derivative of arcsine is this stuff in the bottom, but you know, that's kind of the rule that goes with any u substitution, is being able to spot that. Let's do one that looks a little, that's maybe a little trickier. Suppose we have, let's say, 1 over the square root of 1 minus 4t squared dt. Okay, now in this problem, if you think about the formulas we were just looking at, it looks a whole lot like the arc-sine formula. Right? The arc-sine says you have the square root of 1 minus a variable squared. Well, I want to make this problem look a lot like this one. And here's how you go about doing that. Okay? I can actually rewrite 4t squared as the quantity 2t squared. Remember, if you put it in parentheses, you square both parts. So if I square 2, I'll get the 4. If I square the t, I'll get the t squared. And here again, you do another u substitution. You can let u equal 2t. du will be let's do 2 more. So again, I'm trying to find a couple good problems here. Okay, suppose we have the following. Suppose we have to integrate x plus 9 over x squared plus 9. Well, in this problem, I think, well, if the 9 wasn't there, it looks like a u substitution would basically work. If the x wasn't there, I could basically factor the 9 out front, and then I would be using my arctangent formula again. So when that happens, that tells me maybe I should bust it up. I'm going to break up my fraction as x over x squared plus 9 plus 9 over x squared plus 9. Right? Because if I've got common denominators, if I put them back together, I'll get the same thing I started with. And I'm leaving a little space because remember, if there's pluses or minuses in between your terms, you can integrate those separately. So I'm just going to integrate each piece of this separately. For the first piece, I'm going to again do a u substitution. I'm going to let u equal x squared plus 9. So du is simply going to be 2x dx. Well, all I need is a single x dx. So I'm going to divide both sides by 2 and have 1/2 du equals x dx. And that's going to allow me to rewrite the first problem. I'll pull my 1/2 out front. So my x dx is being replaced with the 1/2 du. And then instead of x squared plus 9, I'm replacing that as a u term. And then for the other one, I'm just going to pull the 9 out front. And then I'm simply going to have 1 over x squared plus 9. So this is your a squared plus x squared. This is your arctangent formula again. So if you integrate this, you'll get 1/2. Remember, if you integrate 1 over a variable, you get the natural logarithm of the absolute value of that variable. So the 9 is along for the ride, and remember the formula. If you think about 9 as being 3 squared, you'll get 1 over 3 arctangent of x over 3 plus c. And now I'm just going to clean it up. I need to plug I started with x's, I want to finish with x's. So I'm going to have 1/2 ln of x squared plus 9, because that's what I called my u term back up here. Well, 9 times a third is 3. And I've got arctangent of x over 3 plus c left over. And that'll be it. Alright, let's see. Maybe one more. Do one more here. Suppose here I want to integrate, let's make it 1 over 9 minus x squared. Okay, and this problem, I think there's a very useful idea here. So this is kind of, I think, an important problem. So again, if you compare, this looks a lot like the arcsine formula, only the arcsine formula says underneath the square root you need to have a 1 minus a variable squared. Okay, it has to look exactly like that. So I'm going to make, well, my problem look exactly like that by doing some algebra first. Okay, again, it says instead of a 9, I would like to have a 1 there. Well, I'm going to make that a 1 by underneath the square root. I'm going to factor a 9 out. So 9 times 1 is 9. And then I can rewrite, I'll have to rewrite x squared as x squared over 9. Because again, if I distribute the 9 out underneath the square root, I will get 9 minus x squared back again. Okay, remember, if you have two things being multiplied under a square root, you can take the square root of each thing individually. So the square root of the 9 is going to come out as a 3. And then I've got 1 minus x squared over 9 left. But again, I want to rewrite that as a quantity squared. So I'm going to rewrite that as x over 3 squared.